Jason, I'll have you know that your discussion some months ago about your 49-inch monitor incentivized me to buy one, and so now I'm going to go on my 49-inch monitor.
Okay. Yeah.
At the standing desk that I purchased for myself recently, because it feels weird to teach sitting down to me.
Yeah, absolutely. Oh, it's life-changing, isn't it?
Look at how the human spirit adapts to its surroundings.
Jason's household is now the proud owner of two 49-inch monitors.
Yeah, my wife just got one.
Yeah.
She got a promotion at work, and she's like, and I'm going to go ahead and get one of those now. And I was like, is work paying for it? She's like, they are not. We're just getting it.
No. If I can have that conversation with my husband, babe, I got to use Jason's once, and it's really difficult to go back. Okay, so let's, yes.
Maybe you better not compare size with another man.
Oh man, he's
so bad.
True.
Bad.
Hello, everyone. This is pre-show banter, where we talk about nothing. Thanks for showing up.
Like a Seinfeld episode.
Mm-hmm.
It really is.
Yeah, it really is. Yeah.
Yeah. What did you do today?
Who are you asking?
Yeah, what did you do today?
What did you do today? What'd you do? What did I do? What did I do? I did this. This is what I'm doing today.
That's an episode right there.
That's an episode.
That's an episode.
When the bandit hosted a webcast.
How Ryan can't get his audio to work?
Yeah, it's
My audit's working great.
we could talk about favorite Seinfeld episodes.
So Ryan and I have been working together for 16 years, and Ryan, if you don't know, has the world's thickest glasses.
Oh, yes.
Today, and it's okay. But I put Ryan's glasses on one time, and I almost vomited instantly because it was just and Ryan and I used to do photo shoots together, and I would tell the models, the talent we were working with, that Ryan was legally blind, and he's really overcome this handicap to
Yeah.
I don't know where to go with that.
This is sounding like a Me Too moment from the beginning.
That's so funny. Jason had led me to believe that Ryan was his actual brother for a good 4 hours, I think. 4 or 5 hours when I first. So Ryan came up here to shoot their vow renewal ceremony. And you did not tell me that he was not. I don't know why I thought he was your brother, but you just let me believe it. I was like asking like how much older you are than him, and he was like, I don't.
Jason's like related to everybody.
Yeah. I hired the whole family to come work here.
Ryan's actually my half brother from my father's third marriage, so he's a lot younger than me.
Exactly.
Hired my sister, hired my brother. Just really got the whole family going here.
The whole family.
I don't think John can do it. Maybe it's okay.
Sure.
I realize you can see somewhat. You can see my tattoos through the shirt.
That's a weird shirt.
He's too sexy for this webcast. Too sexy for this webcast.
Either your tattoos are very, very bright, or your shirt is very thin. Or both.
I have a feeling Ryan's going to add this to the pre-show banter for the recording.
Yes.
Maybe.
I'm
going to wait for the part where someone runs in and dumps water on you. You have the wet t-shirt thing going on.
I'll
relate to those tattoos.
He reaches up and pulls down the bucket.
This is not an X-rated show.
Let us not forget the actual webcast webinar.
We got time.
Bruce, don't forget about that. I don't need to do this.
We'll just talk about nothing for an hour.
We can just do pre-show banter for 90 minutes.
Let me see. Hang on. Somebody wants a pre-show banter. Astro 2 Cyber. What's a 1 hour banter?
Mm-hmm. We could do that. We could have Hal would be the guest, and we would just talk to Hal for an hour. Not today, but in the future. What do you think?
Mm-hmm.
Thoughts?
Yeah. That would really cut down on all the preparation stuff.
Yeah, no slides.
Just show up. Like the description is, what did you do today? That's the show.
Hey, Hal, did you see this one? I can't believe Hal looks like the same as he did when I took his class in 2001. How about that for a nice shout out?
I feel like that's a 2001 reference to Hal. Like,
Yes, it is.
It's drinking blood every night that keeps me youthful.
ah,
Let me talk about my scariest Sands moment in Las Vegas.
Yeah, 2001. Good times. No, sorry,
No, it would have been
2012.
2001.
2012.
It would have been 2012.
Yeah.
that was the
Yeah.
year the Mayans said the world was going to end. And
Oh,
look at
that's
us now.
My world nearly did. So
Yeah, it did.
Interesting. Do you want to talk about that? You want to?
oh yeah, so day one, I teach my 506 class,
Mhm.
and I'm in. I leave class. I go to one of the staff rooms, and I'm chatting with people, and on my way out the door, I just like fainted. I keeled over backwards, smacked my head on the concrete floor at Caesar's Palace.
It was
Wow.
a big blood stain.
Yeah. So it's now a shrine. Like people travel to Caesar's Palace to touch the place where I bled on the floor. It's been known to perform miracles. And so I got carted off to the emergency room in a hospital, unconscious.
Grief.
And poor Rich and Dave got handed the books for my class and said, "Okay, you're teaching tomorrow. Good luck."
They did.
That's crazy. Good
So-
grief.
So I missed. I did day one. By the way, I have no memory of teaching day one. I lost 16 hours of memory. So I
Wow.
can remember being in the classroom before class started and talking with the students and handing out
Hmm.
USBs and stuff like that. But I remember nothing for the rest of the day until I sort of came to in the emergency room at
Wow.
2, 3 in the morning or whatever it was.
Why did you faint? What was wrong?
They don't know. So just before I passed out, I dropped one of my tea mugs on the ground. So I bent over, picked it up, walked a couple of steps, then passed out. So they're calling it orthostatic hypotension. Basically, that lightheaded feeling you get.
Yep. Hmm.
You stand up suddenly. Yeah, I got
Yeah.
that too much. So
Good grief. Yeah.
Yeah, I get that every time I do a burpee. Like for real. Like if I do one of those like jump up, down, and it's like
When was the last time you did a burpee, Jason?
And why would you do a burpee?
I was in when I turned 40, I was like, I want to get in shape, so I decided to do MMA and some boot camp style training. It lasted a couple months.
No shame.
Yep.
Burpees are no fun.
I gave up. I quit. I strategically quit.
You did it on purpose.
Yeah, I chose to quit because it was not bringing me joy. And
did you at least get some money for taking a dive? If you're going to go out.
well, you are the gambler, so
Exactly.
I understand. I understand the name now. You miss Sad Plant?
Yeah.
So Sad Plant, so partially the sun hit him, lost like one of his heads or whatever. But he's got this massive stalk growing out of him right now that's like doubling in size every day. So he's going to look very different when he comes back in the fall.
He's gonna be happy plant.
He's going to look more like a mutant that wants to throw himself off the shelf.
Yeah, it's the challenges. Thankfully, everyone has the same challenge.
Where's the Parmesan cheese?
Hello, everyone. Thank you for joining us for the Hackin Cast on Wednesday. We try to do this every Wednesday. Today, we have Hal Pomeranz, one of our most favorite people here, to talk to us about Linux forensics. Hal, it is all yours.
Woohoo! Linux forensics. That's crazy talk. Well, let's talk crazy. Hey, it's been a little while since I got a chance to do one of these Hackin Casts with the the crew. I've honestly been busy forensicating. Been working on a big in terms of volume Linux forensics case. So, but here we are again. If you want me to answer a question during the webcast, send it to the @WWHF link, and Deb or whomever can break in, because it's hard for me to monitor the Discord while I'm presenting. So if you'd like me to answer during the presentation, send it to them and they can let me know about it. Otherwise, if you @ me, I'll answer the question, but I'll answer it later after the class is over. Cool. So a little bit about me, I guess, before we get started. It's been a long journey in IT for me. No, I started this back in the 1980s as a Unix admin. That turned into being a security admin, systems programmer, network engineer, whatever. And that morphed me into doing incident response and forensics. And now since the late 90s, I've been running my own consulting practice. The practice is now pretty much entirely digital forensics, expert witness work, incident response, that world. And we can have a long talk about how I ended up there, but it's been what a long, strange trip it's been. I'm kind of known as the Linux forensics person. And so as the Linux forensics dude, I tend to get more Linux forensics cases, I think, than the average person. I put together some of that knowledge into a 2-day class, which, yes, we'll be offering at Wild West Hackin Fest, and I'd love to have you in class, so please immediately drop everything you're doing and go sign up. But if you can't, for whatever reason, I've actually made the class available through a Creative Commons license. And so that's the archive.org link that you see on this slide. If you go to archive.org details Hal Linux Forensics, you'll find not only the full course notes for the class, but you'll also find a virtual machine with all of the lab exercises that you can download and study on your own time. So I'd love to have you in class at Wild West Hackin Fest or at some point in the future. But in the meantime, I think it's important that we get this knowledge out there. So, please do feel free to download the course and try it out for yourself. So this material is a little bit of material from that course, but I've also plussed in some value-added stuff that's not going to be in the course. So it's a little bit of everything. And I was thinking, all right, last time we did one of these magical mystery tour things in Linux forensics, I did, kind of low-level file system stuff, and that was fun in its nerdy way. I thought, what do I want to do this time? And I decided, let's do logs. People like logs. That's boring stuff, man. There's nothing interesting to say about logs. Oh, really? No, there's lots of good stuff to say about logs. You will love logs. You will love them, especially after I get done talking. So let's talk about logs and maybe some interesting stuff about logs that you didn't know. All right, so Linux logs. Generally, you're going to find them under var log. I mean, that's a convention, right? The logs could end up in lots of different places. And so, looking at your log configuration before you start forensicating is a good idea, just to make sure that there aren't logs lying around in strange directories that you don't know about. It's also possible that logs are getting shipped over the network to some collection point, like a Splunk server or a SIM or something like that. And knowing that is interesting because, for example, your adversaries may have deleted some of the logs from the local system. So if there's an offline copy, you may be able to more easily recover some of those items. And what's really interesting is when your adversaries edit the logs and remove selected entries. Because then, if you have an offline copy, you can do a diff. And then that's really interesting because the stuff that's different is the stuff you want to look at first. It's the stuff your adversary thought was interesting enough to warrant being deleted from the logs. In general, logs in Linux are in text, at regular ASCII text, although we're going to look at some Linux logs that are in a binary format as well and have some fun with that. But generally, Linux logs are text, which is useful in a lot of ways. I mean, in terms of storing and searching. Also, in terms of recovering logs, I'm going to show you some patterns that you can use to search for deleted logs in the unallocated portions of your drive. The one thing you need to know about Linux logging is that in almost all cases, logging in Linux systems is completely discretionary, right? In other words, it's up to the application developer to decide what they log, when they log it, and in what format. And so Linux logs are a bit of a mess in that respect, particularly as you start aggregating logs together and trying to put them into a searchable database, like parsing all of those differently formatted logs into a form that you can do something useful with them is truly one of the annoying pieces of log aggregation. But what this also means is that, if your adversary is deploying custom software in the Linux environment, they're not required to log anything. And of course, they're not going to, right? So when they install that backdoored SSH daemon onto your system, that daemon isn't going to log, the attacker's secret logins onto your system. And one of the things that I've seen in a number of incidents is the attackers will get onto the system and they'll try and reduce the amount of logging that the system is doing to try and, obviously to hide their behaviors on the system. And sometimes the attackers get that wrong and they end up accidentally completely disabling logging on the system. And I would urge you, in your environments to look out for that condition. If you're collecting all of your logs together into some, ginormous storage system, have an alert that goes off if you stop receiving logs from a system. Like if you haven't gotten logs from your Linux box in like an hour or two, you should probably have somebody go look at that box. Now, 9 times out of 10, it's just that the box is, hosed up. The syslog daemon is gone awry or whatever. But occasionally, it's an indicator that the machine has been compromised. So it's a good alert to have for various reasons, but not the least of which is it can actually alert you to attacker activity on the system. So let's take a look at a couple of the more popular log formats that you're going to have to deal with in Linux systems. And this first slide is the kind of classic syslog style Linux log. Now, the first part of these log messages is very regular, right? So there's a date and a timestamp that you see at the front. Now, a couple things about that date and timestamp that are worth mentioning. First off, notice that there's no year because when Unix systems were first being developed, nobody could imagine maintaining logs for more than like a few weeks. Like, why would you ever want to keep your logs around for longer than a month or so? And so they didn't bother putting a year into the date stamp, which is a problem now, that we're starting to archive this log data for very long periods of time. You got to figure out a way to plus that year information into the logs, when you put it into archival storage. But it also becomes an issue when you're recovering deleted logs from, unallocated. If you pull back a log entry and it says October the 5th, is that October the 5th, 2020? Is that October the 5th, 2019? You don't really know. Oftentimes, there are clues in the log messages themselves, right? So the text of the log message might include a date stamp, like messages from the kernel about when the system was booted and things like that. But yeah, so no years in the date stamp. Also, the other important thing about these date and time stamps is that these logs are written in whatever the local default system time zone is, right? So you need to know when you're analyzing these logs, particularly when you're trying to analyze logs from multiple systems that may be in different time zones, you got to know what the time zone is for each system, because you may have to adjust the log timestamps to make sense. And there's no indication in this log format what the time zone offset is. So you need to look at other artifacts on the system, like the Etsy local time file, to figure out what that default time zone is. Dealing with a case where during the period of the incident response, the admins actually changed the time zone on some of the affected systems while we were in the middle of the IR. And wow, it's like, oh my God, the log's timestamp changed, and there's no indication, that somebody was messing around with the time zone. So suddenly just like the timestamps jump backwards 4 hours. You're like, so anyway. So yeah, after the date and timestamp is the host name of the machine. So this is one place you can go on a Linux system to figure out what the system thinks its host name is, because each log message, that's written on the machine is going to have the host name of the machine in the log message. I dealt with a case a long time ago where our adversaries became aware that we were about to visit them and collect their electronic evidence. So they decided before we got there that they were going to wipe their machines. Unfortunately for them, wiping the machines meant overwriting the operating system with a brand new operating system, but not actually wiping the disk drive. So when we got there, we found this sort of virgin, unused operating system up at the front of the drive. And then the rest of the drive was all of the remnants of the old operating system, including old log messages that clearly showed what the name of the system used to be. And that system name information actually turned out to be quite useful for our case. So you can also detect things like changes to the host name by pulling back and looking at old logs. After the host name is going to be the process name of the process that's sending the log, and usually the process ID as well. And then after that, who knows? This is the part where the logs just get completely messed up, because people and applications can log whatever the heck they feel like in whatever format they want. So you can see here just this small sample of logs all have radically different formats from one another. And this is just a minor blip on the total number of weird logs that you can get here. Now, this log format, particularly the date, the time, and the host name, that forms a very regular pattern, and you can use that to recover deleted logs from unallocated. And so I'm going to talk about that in a second. I'm going to give you some patterns, some regular expressions that you can use to look for deleted log entries. So, if attackers come in and they RM your logs, you can probably recover them using some trickeration that I'll show you in a minute. So the first part of the logs is very regular, but the back half, not so much. Not so much. And then here's another type of logs that we're commonly dealing with in investigations. This is the Apache style web log format. Strictly speaking, this is the NCSA HTTPD log format, because this was originally created by the developers at NCSA for the original web server that we all used to use back in the early 90s. Apache grew out of that web server and kept the log format. And a lot of other web servers in the Unix environment also use this logging format. And I'm not a fan, but it's the format that you're going to have to deal with most often for web investigations. And given that a lot of exploits these days are exploits against vulnerable web applications, you're going to spend a lot of time looking at these logs and parsing these logs. So the breakdown on these logs, the first field is the IP address, sometimes host name, of the source of the web request. Okay, so this is the person who's asking for the object from your web server. The next two fields are generally dashes. Back in the olden days, the first dash, the second field of the log, that first dash was supposed to be the remote username of the user making the request. And you were supposed to fill that in using the old ident protocol that even at the time, nobody allowed through their firewall, right? So that field is almost always a dash because you don't have a client username to fill in. The third field, the second of the two dashes, is the authenticated username on this web server. And that one's only filled in if the web application is using one of the built-in authentication systems in the web server, like basic auth or something like that, which again, nobody ever uses anymore. They're always using some authentication system that's built into the web app that uses, session cookies and things like that. So generally, both of those fields are going to be dashes. And then comes the world's worst date and timestamp. I want to find the person who thought that this was a good date and timestamp format and just give them a big hug, because really, they got it wrong. What is this? We've got a date that is completely unsortable, right? It's day first, then month as ASCII, and then year. Like, I can't sort that. I can't do anything with that. And then the time, again, written in local time for the web server. Now, the one thing I will say in favor of this format is that it does give a time zone offset. So that plus 200 you see after the date and timestamp, that is the hours offset from GMT. So these times are being written plus 2 hours from GMT or Central European time. So, at least it's got that going for it. It does show the time zone offset. But again, this format, while it is awful, is also incredibly unique to these web server logs. And it's a pattern, again, that you can look for deleted web logs. Okay, after the horrible date and timestamp. Oh, actually, let me tell you one more weird thing about the timestamps in these web server logs. They can appear out of chronological order. Wait, what? How does that work, Hal? Okay, so let me explain this. The timestamp is the time in which the request was received by the web server. Okay, so that's the time that the request came in from the remote host. But the logging is only done to the log file when the request is completed by the web server. So what happens is you get request A comes in, right? It comes in at, let's say, noon. And then request B comes in 1 second later. Noon plus 1 second. Okay, request B is a very small request. It takes less than a second to be serviced by the web server. It gets done, boom, request B gets logged into the log file. Okay, request A, though, meanwhile, has been also being serviced by the web server, but it was like this massive data download that took 30 seconds to complete. And so as soon as that 30 seconds is up and the web request is complete, then whack, the log for request A goes in with a timestamp of noon. But in the meantime, request B and all of the other requests that have come in and been serviced during the 30 seconds that request A was being processed are all in the log. And then suddenly there's A with an out of order timestamp of noon. So the reason the timestamps are sometimes out of order in this file is that they're logging the time of the request, but it's only being logged at the time the request is completed. So don't freak out when you see things out of chronological order. It just means that some requests took longer to complete than others. So after the timestamp, you see, the request method, get post, the URL being requested may or may not include the query string that's configurable in the web server configuration. My vote is yes, include the query string, because there's useful information in there. It can also be something of an invasion of privacy, but in the case where somebody drops a web shell onto your box, you're really going to want the query strings. And then, of course, the HTTP protocol version. Following that, you've got the result code as returned by the web server. 200 means everything's good. The request worked out fine. 300 is a redirect. The web server told the client, oh, what you want to look for is over there at that URL. So all of the 300 series are redirects of one form or another. 400 means the client messed something up, like 404, not found. The client asked for something that didn't exist. Or 403, the client asked for a protected document that requires authentication in order to access. 500 means that the server blew up. The server ran out of memory. The server was overloaded and couldn't spawn a new child process. Whatever. 500 series errors are all server problems. And those errors can be interesting. For example, somebody's launching an exploit against your web application that causes the web application to crash, buffer overflow, that kind of exploit. And so you may want to pay attention to sudden upticks in 500 server error messages, because it may be somebody trying to launch an exploit against your system. Following the result code, you've got the number of bytes sent. Okay, that's not the size of the object requested. It's the number of bytes sent. So, for example, somebody makes a request, but the connection is interrupted before the server could send all of the data. Or the client comes back after that interrupted request and requests the rest of the data, which is permissible. And so your server doesn't have to give out the entire object. They just give out whatever fraction of the object the client missed. So that's bytes sent, not size of object, which is an important distinction. But it confuses people because people are like, why am I only sending 10K bytes when this object is 1 megabyte in size? Well, it's because that's all that got to be sent on this particular request. The default log format ends there with number of bytes sent. You can plus your logs up. You can use what's called the combined log format, which includes 2 more fields, refer and user agent. So refer is the page that held the link that you clicked on to get to this page. So if you're doing a search on Google and you click on one of the links to go to a website, the refer will be a Google link. So refer is nice because it can be kind of a reverse trail of breadcrumbs that can lead you back to how somebody got to a particular web resource. The other thing refer is useful for, so you have, a typical modern web page that includes a bunch of CSS, JavaScript, images, and things like that. Those sub-items are downloaded separately, right? Like the CSS file is a separate download. The JavaScript is a separate download. Each one of those, though, will have as the refer the main page that object is embedded in. So you'll be able to correlate all of those objects together. And if you're getting malicious objects, you'll be able to look at the refer field and know what web page had the malicious objects embedded in it. And then user agent string. User agent string is useful for trying to categorize, the browser, or maybe it's a bot, or maybe it's malware, right? Bots and malware will try and use legitimate looking user agent strings, but of course they may get it wrong, and you may be able to track malicious activity using these sort of weird, unique user agent strings that the malware uses. Of course, all of this can be forged, right? There's plugins, browser plugins like Tamper Data. There's intercepting proxies like Burp and WebScarab and Fiddler that allow you to modify any of these things like the refer or the user agent string on the fly. So, you can't be certain that this data hasn't been tampered with, but it can still be useful information. Okay, so you come in for your investigation, you want to start looking at these logs, and you discover that the attacker has deleted one or more of the log entries, right, or log files. I've had very good luck recovering deleted logs using patterns like these time and date stamps, which are very unique to these particular log formats. This is also good, if I get into an incident response and the exploit happened, months ago, and the normal log rotation cycle has rotated all of the old logs away, I may still be able to recover some of the old logs from unallocated from around the time of the incident. And so I just wanted to give you a couple of useful patterns, right? So you remember those syslog style logs that we looked at here, right? What's the date stamp? It's a 3-letter month abbreviation, and then some white space, and then the day of the month, and then some white space, and then a timestamp, digits, digits, and then the host name of the machine, right? Okay, so I can write a pattern for that. So capital letter followed by 2 lowercase letters, followed by some white space, followed by the day of the month, which is 1 or 2 digits, followed by white space, followed by a timestamp, digits, digits. You'll get better results if you also can include the space, host name space of the machine. You'll get less false positive matches that way if you can include the host name. That's a good pattern for finding, deleted or rotated logs in unallocated. For Apache, it's the world's most annoying date and time format. So it's the day of the month. It's a square bracket, the day of the month, so some digits, slash, capital letter, 2 lowercase letters, slash, the year, it's a bunch of digits, colon, and then the timestamp, digits, digits, space, plus or minus the time zone offset, which is a bunch more digits, and a closing square bracket, right? Nothing else in your system looks like that timestamp except Apache web server logs. And so it's a good timestamp for recovering those old logs. Now, how do you use this? I tried to give you an idea. So using like a tool like BlockLS from the Sleuth Kit. So like run BlockLS against your root volume or wherever the var log directory is supposed to be. BlockLS will pull out just the unallocated blocks from the system. Once you've got those, just run the strings against the unallocated blocks and pipe that into egrep using one of these patterns, and out pops whatever recovered logs you can find. Works really well. Really well. So just FYI, so a little trick for recovering deleted logs or logs that have rotated, and it will serve you well in your investigations. Deb, any questions before I move on to the next topic?
Actually, yes, we do have a couple questions.
I'm so glad I stopped.
Perfect timing, yes. If you change the log by adding a year, do you invalidate it for legal actions?
So like when you're putting the logs into your long-term archival storage. Modifying the logs by adding a year, it's still a business record as far as the courts are concerned. So I see no problems with, plussing the data with a year field as you're, putting into archival storage.
Perfect. Is it possible for an attacker to change the timestamp on the log?
Certainly. I mean, again, the logs are just text, and the attacker can make whatever modifications they want. Syslog logs are generally chronological, though. So if the attacker is going to change the timestamp, they also need to move the log within the file so that the timestamp makes sense within context. But other than that, there's nothing at all preventing them from messing around with your logs however they see fit.
Awesome. Then that's all I have for you. Back to you.
Cool. All right. Thank you. Okay. So, we were talking about some of the common text log formats on the system, but there's also some binary logs as well that you run into. So, for example, the WTemp file is a record of, last logins, basically. This is the login history, if you will, from the machine. So, and I just happen to have a Linux system here. So these binary logs, you can't just look at them with a text editor or less or whatever. I'm a little blurry. Okay. Yes, focus better now. It's like Dr. Tung's 3D House of Linux. Okay. So WTemp file being a binary file, you can't just open it up in, less, Emacs, Vim, whatever. You need a program to translate it into text. And that would be the last program. So if I just run last from the command line, this is the history of logins on my system, at least as far back as March 13th. And so you see who, the PTY they logged in under, where they came from. So this would be the IP address of the source of the connection, when they logged in, and the duration of that login. This log also tracks system reboots. So you get that information for free. If you look down here, you'll see an entry like this where the source of the login is listed as :0. That means somebody logging in on the graphical console of the system, the X Windows console. Bear in mind that this WTemp file only logs fully interactive user logins. If somebody just, SSHs into the box and runs a single command like SSH, this host, ps-ef, that doesn't get logged in the WTemp file. What gets logged in the WTemp file is only if somebody, actually logs in and gets a shell prompt, basically. So these are full interactive user logins. By the way, even though this is a binary file, there are tools available from various underground websites that allow you to edit the binary WTemp file and remove records from the file. So just because it's a binary file doesn't mean it can't be tampered with by your attackers. Okay, so if I just run the last command, I'm getting the login information about this machine that I'm on, right? Which is my Linux lab analysis virtual machine. But suppose I wanted to look at the WTemp file from a forensic image that I have mounted up, and I just happen to have one mounted up. So if I CD over into my mount test data var log directory, right? So this is the logs from a test system. And there's a WTemp file here, but how do I read it? So the last command has a -f flag that lets you specify a file name that you want to run against. So now I'll be looking at the last output from this virtual machine image. And, you can see logins from the mail account That shouldn't be happening, right? The mail user on the Linux system is not a user that somebody should be logging in as. So that's a bad sign. And you can see the IP addresses where those logins are coming from and so on. So last -F to look at a different WTemp file than the one from your local machine. In addition to WTemp, on some systems, there may also be a btemp file. This is failed logins. Okay. The btemp file does not always exist. It needs to be manually created by the system's administrator. The reason you might not want to have a btemp file on your system is it logs the username of the failed login. And the problem is, one failure mode is users getting messed up and typing their password at the username prompt. And what will happen is that clear text password will then be stuffed into the btemp file and be visible to anybody who can read the file. So that's why some people don't like enabling btemp logging, because it can end up disclosing user passwords if they get out of sync during the login process. But the btemp file can show you some interesting stuff. You read the btemp file with the last B command, and again, it has a -F option. So I'm going to read from the btemp file from my forensic image. And this is going to generate a lot of output, so I'm going to pipe it into less. Okay, so there was a failed login as the mail user from that 210.131 IP address that we actually saw some legitimate logins from in the last output. So maybe they just mistyped the password or something like that. But roughly half an hour prior to that failed login as the mail user, we see a bunch of failed logins as the root user. And I mean, look at the times, right? There are literally dozens of these happening within the same 1 minute interval. So that's not an interactive user process, right? That's somebody doing a brute force password guessing attack. And this goes on for miles and miles, right? Endless. Right. Let me just jump to the end. It goes all the way down to like 1042. So from around 1052 to 1042, there's a whole bunch of these failed root logins. And so, somehow, they were trying to get logged in as the root user. Maybe that didn't work. And so they found some other way to break into the system. But, this is the kind of useful stuff you can get out of the btemp file. You can see these sorts of brute force guessing attacks. There's other places you can get that information as well. The SSH logs on the box will show that to you also. But it's a nice sort of consolidated view of those. So that's the btemp file. The last one I wanted to mention is the last log. So, if you've ever logged into a Linux system, when you log in, it says, hey, welcome to the system. Your last login was at this date and time on this PTY. That information is stored per user in this last log file. So the last log is information about the last login for each user on the system. Now, if the login was recent enough, you could probably get that information from the output of the last command or by looking at the SSH logs on the system. But if it was a long time ago and the logs have rotated away, this could be one of the few places that you can see the last login for a particular user. So if I run last log, I'm seeing, the last login for different users here on my lab VM, right? So root has never logged in, but the lab user that I'm logged in as, right, the last login was today from, my host operating system, the .1 address. Okay. So, so that's how we would look at it on my local machine, but what about the last log file here in the var log directory of the forensic image that I'm investigating? It's not like last and last B. There's no -F option, right? What you do instead is you say last log -R to root to the directory where you have the image mounted up, because the last log program needs the password file from the machine to have the list of users that it should check to see who's logged in. So it's not just a question of having the last log file itself. You need the user database from the system to be able to present that information in a meaningful way. Here's the problem. The format of the last log file is highly variable. For example, it's different on 32-bit systems as opposed to 64-bit systems. It's different from version of Linux to version of Linux. It's changed a lot over time. And so what you'll find is that the last log program on your analysis machine may not be able to read the last log file from some older alternate CPU architecture forensic image that you're looking at, right? So if I try and run last log against the mounted image under mount test data, I get no output back because of incompatibilities in format. And so you're thinking, oh, okay, well, what am I going to do about that? Well, let me try running the last log program from the system that I'm investigating, right? So rather than running, user bin last log on my local analysis machine, what if I tried to run mount test data user bin last log? Or is it just bin? I think it's user bin. -R mount test data. Ooh, permission denied. Permission denied because, being a careful forensicator, I mounted this file system no exec, right? I'm analyzing an infected Linux machine from a Linux analysis workstation. The machine I'm investigating may contain Linux malware, which I don't accidentally want to investigate. So I've got my image mounted up no exec. So I can't accidentally execute things. But that also means I can't execute the last log program. Okay. But I really want to look at the last log data. So what I'm going to do is a little bit of kung fu. So I'm going to mount with the remount option, which means I'm not actually unmounting the file system. I'm just changing some of the options. So I'm going to mount read only, but remove the no exec flag. So I'm just going to mount it read only without no exec. And what am I mounting? I'm mounting this device on mount test data. So the remount option says don't actually unmount it. Instead, just update the options with the option list that I'm giving. And now you can see that no exec is not set. So now let me go back and try that last log command. Ooh, denied again, right? And it's complaining about, shared libraries. Because what's happening is I'm trying to run this last log program from this, older Linux image, and that executable isn't compatible with the shared libraries on my analysis workstation. So let me show you the ninja trick on this one. If you really, absolutely positively have to look at this last log data, do this instead. Run the chroot command from the command line. Invoke the last log command. Oh, actually, I need to give it, sorry. Chroot yourself to the place where you where you have the image mounted, and then invoke the last log command within that ch-rooted restriction. And there's your output, right? So the trick is, first you've got to, if you have it mounted no exec, you've got to remount it executable, and then use the ch-root command to actually run the last log command within that mounted image in the context of that mounted image with all the shared libraries from that image. Bearing in mind, of course, that, there may be a shared library-based rootkit on that image. I'd only do this on a machine that I didn't really care about the outcome. Because if that machine infects your guest operating system, that's not good. So anyway, but this is the trick. If you really need to look at that last log data, this is a rare thing, but it's one of those, ninja skills that can help you on every once in a while. And you look like, a genius because you're the only one who can figure out how to get at this data. What the world really needs, and someday I'll sit down and write it, is a last log file parser that is independent of things like the local password file and things like that. It should just be able to interpret all of the different various last log formats and produce meaningful output without having to do this ch-rooting nonsense. That would be a useful Linux forensics tool if anybody wants to sit down and write it. But there's a lot of variations in format of these last log files that you're going to have to deal with in your tool. All right, cool. Deb, I'm going to open it up for questions.
Perfect timing, as always. A couple questions. If WTemp only logs interactive logons, where would we find logging for non-interactive logons?
Yeah, so for non-interactive logins like SSH, commands, you got to look in the syslog style logs. So wherever your auth or auth priv logs end up. So for example, on this system, there's a file called varlog auth-log, right? So in here, there's going to be all of these SSHD logins, and this logs everything. Any SSH connection succeeds or fails is going to end up in one of these syslog style logs. So that's where you would go to look for the non-interactive logins as well as the interactive one.
Why would my last log show the currently logged in user as never logged in?
Why? Okay, yeah. So I'm not sure when the last log information gets updated. Maybe it only gets updated when you log out. So try logging out, then logging back in again and seeing if the last log gets updated.
Okay. All right. We'll save the rest for the end.
Okay, cool. All righty. Okay, so let's talk a little bit about kernel level auditing for just a sec. So for a long time, the kind of standard syslog style logging was pretty much the only thing that was available. But as Linux started moving into higher security environments, there was a desire to have higher levels of auditing that was mandatory, right? So the problem with Unix logging is that it's discretionary, but the higher security environments wanted mandatory logging that couldn't easily be disabled or subverted. So this kernel level auditing, which most people kind of refer to by the name Audit logging. Audit is the user space daemon, which takes the logs from the kernel and writes them to disk. So this Audit style logging is the Linux version of that mandatory kernel level auditing. Most Unix operating systems have this. Solaris calls it BSM, their basic security module. On HPUX, this is trusted mode. This is the level of auditing you get in trusted mode. AIX has this as well. This is, an unbelievably powerful level of logging. Think of this as sysmon for Linux systems, because it can literally log every single system call that goes through the kernel. However, there haven't really been good standards for what to log. And doing something with the data is also problematic, as you'll see. There aren't a lot of really good tools for digesting these logs and turning them into actionable events. But, after an incident, this level of logging is unbelievably useful because it can, for example, show every single process that executed on the system. It can show things like privilege escalation because set ID is a system call that can be tracked. You can see users opening files. You can even get down to the point where you're actually logging keystrokes with this. Tim Medine over at Red Siege has published a blog article based on a conversation that he and I had about this. But basically, you can also use this as an attacker. Like, I can break into the system and turn on the keystroke logging functionality and use it to steal users' passwords. So it's a bit of a double-edged sword. So as far as, a starting point for configuring this in your environment, the Center for Internet Security has some good guidance in their Linux security guides, particularly their Red Hat Linux security guide has a sample audit deconfiguration that you can use as a starting point. Another one that I might recommend is, let me fire up a new window. Over at github.com, here we go, bfuzzy, there is a node called Audit D Attack. Okay. So this is bfuzzy's Audit D Attack project. This is Audit D rules that are mapped onto the MITRE attack framework. And so it's, trying to use Audit D to look for some of the adversary TTPs that are encapsulated in the MITRE attack framework. And so this is another, straw man set of Audit D rules that you could use as a starting point for your own rule base. And I'm not going to get too much into configuring Audit D because that's like a whole, webinar in and of itself. And maybe I'll come back and do that talk at some point. But, what you get once you've configured this, even if you don't configure it, even if you just install the basic Audit D packages on your system and do no configuration, Audit D will automatically log user logins, user logouts, scheduled tasks, right? Even without you doing any other configuration. And that can be useful in and of itself, right? Maybe the attackers come in and they remove that var log secure file with all of your SSH logins, right? But they forget about the audit logs. And so even though they've trashed your regular syslog style logs, in your audit logs, you still have a record of all of the user logins and things like that. But, if you configure it, you can also audit just everything else that's going on the system. File accesses, kernel modules being loaded, blah, 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 blah. The sky's the limit on this if you know what you're doing. But like sysmon, right, if you turn on too much, you can also really slow down your machine. So you have to be selective about what you're auditing for and only go for the high value stuff. Here's an example of, reading one of these audit logs. Now, the audit log files themselves, they're just text-based files, right? I've got a sample audit log that we can take a look at. So images lab 8. right? So here's an audit log file. If you want to read the audit logs from, like, your mounted forensic image or a copy of the audit logs, you can look at them with a text reader like Less, right? But the problem is, look at this log, right? It's really not terribly easy to read. Right? There's a lot of detail and a lot of noise, and then you start looking at this and you go, wait, there are no timestamps, right? Right? You look through this log. Right? So here's a user login record right here, right? And you can see, the address, that the login came from. But when did that login happen? There's no timestamp. Oh, no, there's a timestamp, right? Spot the timestamp? Yeah. That's the timestamp. It's in Unix epoch format, which is, of course, how the kernel keeps time, but it's not really useful for human beings. Now, you can convert epoch timestamps on the fly. I showed you how to do that in an earlier one of my command line kung fu talks. You just do date minus D @ and then the epoch time value is 2, 4. Okay, so that date corresponds to July 14th, 2017. Okay, so you can convert these dates on the fly, but that sucks, right? So the right way to read one of these audit log files is not with a tool like Less, but instead to use this specialized searching tool that's provided with the auditing subsystem, and that is the Ausearch tool. So Ausearch, and you can specify an input file, right? So if you don't want to read the audit logs from the local system, but want to read the audit logs from someplace else, you say -if for input file, and then, in this case, audit.log. And what do you want to search for? Well, I want to search for, I don't know, like a command like user add. Okay. Let's try. Let's try the example on the book. Okay, so the advantage to using Ausearch, there are multiple advantages. One is, hey, whoops, it converts the timestamps for you, right? So it shows you a human readable timestamp for all of the matching log entries. What it also shows you is that there are actually multiple audit log records for a given event. Okay, so this is all of the audit log records related to a given run of the user add command. But each event actually triggers a whole cascade of records. They are grouped together by this number that appears after the timestamp. You see, :342. That is the audit ID number that associates all of these records together. Now, there's nothing magical about that audit ID number. It's just a monotonically increasing number. 340. This is 342. The next one will be 343, 344, and so on. And it resets every time the system reboots. So there are going to be multiple audit ID 342 entries in your audit log file because the numbering restarts every time the box reboots. Right? So what do we see here? Well, okay, so there's the syscall record which says, look, it's the user add command that was run by UID 0. Oh, and by the way, the actual user ID that SU'd to root to run this command is user ID 1000, right? So now we're learning which actual user became root to run this command. CWD, you know the current working directory that they were in when they ran the command. What file got modified? Well, the etc password file got modified in this case. And yes, there will probably be another set of audit records that show this user add command modifying the etc shadow and etc group files as well. And then there's this proc title thing, right? And the proc title is the actual command line encoded as hex ASCII. And I'll show you how to convert this into a readable command line using a little bit of command line kung fu. So let me grep for some of these type equal proc title. Yeah. From my audit log. Okay, so here's a nice juicy one, right? So what you do is you take this hex ASCII stuff. I'm going to copy it, and I'm going to say echo that hex ASCII stuff, and I'm going to pipe it into XXD, which is normally a hex dumping tool. It would normally convert binary data into this hex ASCII format, but if you do -R mode, it reverses that. It converts the hex ASCII back into its binary, or in this case, ASCII representation, -P for plain input. Oops. And if I actually type the command correctly, this would be a lot more interesting. Okay, and so you can see user live exec, dbus daemon launch. This looks a little bit messed up. And it's messed up because the data is null terminated. So it uses nulls to separate the command line arguments, not spaces. Also, there's no new line at the end, which is problematic. So what I end up usually doing is something more along the lines of this. So echo the stuff into XXD-RP, then pipe that into TR and translate the nulls to spaces. And also just do an echo to add a new line at the end. See, easier to read now. So that's how we do that. Sexy, right? So yeah, so you can convert these hex ASCII things on the fly using that little idiom. But this is hugely useful information, right? I mean, we get a lot of information if you know what fields are the most important to look for. Now, you can search, by command name. You can search by file name, right? So you can do ausearch -f etc password, let's say. You can search by keyword. So when you're creating your auditing rules, you can tag those rules with a specific keyword that you can search for later. So for example, that audit the attack thing that I showed you, the keyword tags that they use are the actual MITRE framework code numbers associated with each one of those TTPs. In this case, I set my audit rules that any change to something like the etc password file would be tagged with the key auth files. So I can search for modifications to those files by doing ausearch -k and then auth files, or whatever keyword you want to use. In addition to ausearch, there's also Aureport. Aureport gives you a kind of rolled up report, just a summary report. So like, for example, show me all of the syscall type records in my audit log. And so you can see, a roll-up. So like, here's a sudo report. Somebody's running sudo. So I wanted more detail about this item. Out here in the last column, that is the audit ID number, right? So remember 342 in this example? Okay. So for this one, the audit ID number is 784. And knowing that audit ID number, I can now ausearch that audit log file for audit ID number 784. And so here is the sudo one. And again, we can convert this proc title. So that's sudo minus S, right? So somebody sudoed to get a root shell. And who was it? Well, it was, AUID 1000, whoever that is in your local password file. Okay, so there's Aureport, which can kind of give you the rolled up report, and then you can pick and choose the audit ID numbers that you want to look at. There's also the folks at Red Hat also created some other cool little utilities. So there's AU last. Remember the last command? It used the wtemp file to show you a list of all of the recent logins on the system. AU last does the same thing, except it uses your audit log file instead, right? So somebody's gone, they've trashed your wtemp file. They've trashed your SSH logs and var log secure. AU last against your audit log file. And notice this one just uses -f rather than IF. So AU last, it shows you the same thing that last would show you, but this is based on the login records in your audit log, not the wtemp file. So if the attackers trashed one but not the other, there you go. Now notice the order's reversed because AU last is reading through the audit log file from oldest to newest. That's the output that you get. So the newest logins are at the bottom of this, not at the top, like they would be with last. By the way, there's also AU last log. Oops. Which basically does the same thing as last log, but again, using the audit log data, not the last log file. So those can be cool if you believe that the attackers have been tampering with your logs. So this audit log stuff, I mean, it's a really deep subject. And if you're responsible for, configuring your enterprise logging architecture, sitting down and spending some time learning how to configure Audit on your Linux boxes is worthwhile. Obviously, before you have an incident, not after. Okay, so here's the contact information. If you think of questions after the webinar is over. Again, I'm showing you the archive.org URL where you can download the complete course material, which is 9 modules. It's a 2-day class. So there's a lot of material at the archive.org link. And if you want me to teach it to you live, I'll be doing it next at the Deadwood event. And class starts on September the 22nd. So sign up now, and I will see you there. Deb, final questions. Hit me.
Final questions. Yes. Hal, we got lots of mind blown emojis floating around. They wouldn't let me interrupt you, and I wisely did not. Yes, we have some questions. Is there a way to create a Linux account without sudo privileges that can access a system and collect the assets information?
So I'm going to assume that this is for legitimate admin purposes. If you're talking about collecting log information, syslog gives you the ability to send logs over the network, and you don't have to have an account to do that. It turns out that the auditing subsystem also has this thing called the audit dispatcher daemon, which allows you to ship audit logs over the network as well. So you can potentially set up systems to send all of their logging and audit trail over the network automatically without human intervention at all. Or, you could install something like a log beat from Elastic, or into Elastic, I should say, that would collect the data automatically as well. Otherwise, if you're talking about doing it manually over SSH, you're going to have some sort of account. But, my advice is to use the built-in remote logging protocols for all of this stuff and just collect it at some repository, whatever that is for you.
What's the best log to look for program execution?
So the best log to look for program execution would be your audit logs, but you have to configure it. And it's not going to log that out of the box. In Unix, there's this thing called process accounting, which is a legacy from the olden days of time-sharing Unix systems. And you can turn process accounting on and get a log of commands that are run. But process accounting only logs the command name, right? So, for example, you see somebody running the VI program, but you don't see what file they're editing with it. Whereas if you configure Audit properly, you can log every single command and all the command line arguments, and you get a lot more information that way. So Audit is the way to go if you can configure it properly.
Mm-hmm. Let's see. Lots of good questions. They'd like you to talk about recommended tools for gathering the forensic image.
Oh gosh, it depends, right? I have a little bit to say about disk acquisition in the class, and all I'll say about that is be flexible. It depends. What kind of system is it? Is it a system in a public cloud, like Amazon's EC2 space or something like that, right? Okay, then you're going to have to follow Amazon's procedure for making a forensic image, which is basically you pause the instance, you dump it to an S3 bucket, and then you hook that S3 bucket up to another instance that you fired up in the same data center so that you can forensicate it, right? Is it a private cloud? Is it like an on-premise VMware setup? Snapshot the machine and then walk away with a copy of the snapshot. If it's a physical machine, woo, that's all kinds of exciting because, who knows what access you may have to the physical storage media, right? You may have to do something, you might be able to do something easy, like you might be able to extract the storage media and use a disk duplicator to duplicate it. Or you might have to boot the machine off of a Linux rescue disk in DD or EWF acquire the image. I mean, the problem is there's so many different scenarios and every case is different. You just gotta roll with it. Remote acquisition, you could use something like F-Response, throw a shout out to the F-Response product, or an EDR tool, Encase Enterprise, CrowdStrike's Falcon, to extract various artifacts from the system. It's just a billion different ways, and it depends on the environment.
Do you have any open source tools that you recommend to collect memory artifacts remotely?
SSH plus something like either AVML, which you can find from GitHub. Acquire Volatile Memory Linux is what AVML stands for. Or SSH plus something like Lime, Joe Siles' memory acquisition. I wrote a tool that automates memory acquisition called LMG. You can find that at my GitHub, the Linux Memory Grabber. But you need to get onto the box to run the tool somehow. So that generally for remote acquisition is going to mean SSHing the tool onto the box, running it remotely by SSH. You got to figure out where that memory dump's going to go, though. So
we'll do a couple more because we're running a little late. Does Audit log command executions invoked from a shell script as opposed to being invoked directly from an interactive interface? Says he came across a system where a shell script was ran to perform various tasks, but none of the commands were logged.
Well, so certainly Audit can log every command that's executed, even if it's executed out of a shell script. But I mean, that basically means Audit is going to track not, so in my example that I did, right, we looked at this sudo command, and that was picked up because, it was an interactive, sudo command that, doing privilege escalation, and Audit is going to just log that out of the gate. But yeah, to do what you're talking about, which is, like a whole hierarchy of processes that are spawning out of a shell script or maybe like a web shell or something like that, you're going to have to tweak your Audit configuration and tell it to log every single instance of the exec family of system calls, right? That's how you're going to catch every single process, no matter how it started. And then you're also going to get a lot of legitimate, process executions mixed in there. So it's going to make your logs, massively expand. But, out of the gate, it's not going to do that. You're going to have to configure it properly to track those execs.
All right, we'll do one more. Have you encountered any machines which were specifically set to prevent duplicating disks? Something which detects that it's being imaged and corrupts itself?
Huh. I haven't seen that. But I'm not saying it's not out there. I mean, remember, the thing that most is a pain in the butt for disk acquisition these days is encryption, right? If you image an encrypted drive and you don't have a way of knowing the passcode or the escrowed key to unlock that drive, then what you've got is a drive full of gibberish. The other thing that we're seeing now is things like the Macs with the T2 chips. Unless you're using specialized acquisition tools like the recent versions of Macquisition, the T2, the whole trusted boot thing is going to thwart your ability to reliably image that drive. So yeah, in those cases, you're going to need specialized tools that can acquire those kinds of systems. It's been a big pain in the butt for us on Mac acquisitions for a little while now, but the black bag folks are starting to work around it.
Awesome. Okay, well, with that, I'll say we are done with the session. Hal, thank you so much for being here. Always a
Always a good time.
Always good.